Now in this video we are going to locate the moment of inertia of a rectangular area from the first principle of method of integration. I have drawn the figure here. It's a rectangle whose base is B and depth is D. Now to locate the center of this rectangle, what I've done is, because we know the centroid, by looking this is centroid, the point G is a centroid. The line passing through this centroid is called as centroidal axis. This is ixx, whereas this line is a yy. So this centroidal axis which divide the given figure in two equal half along x as well as this yy along y. Now as I told, the central axis passes through the centroid and which divides the given figure into two equal half. Now from this the distance is d by 2 upward and downward. Here I have considered elementary strip with thickness dA. So here area of elementary strip dA is given by, as the depth is dy, width is b. So b into dy is the area of LS, elementary strip. As per the definition of moment of inertia, the elementary strip moment of inertia Ixx is given by y square into dA. Now what I have done is, as we know that moment of inertia is nothing but moment of this elementary strip area about this central axis twice. Second moment of inertia about this elementary strip is known as moment of inertia. Now this, it is very small, so I have written as d, that is smaller elementary strip area moment of inertia, is because the distance between this central axis, it is very small, so the distance between this centroid and this central axis is y. So it is y square dA. Now I wanted to, if I wanted to calculate the moment of inertia of this rectangle, entire rectangle, by making use of this elementary strip area, I supposed to integrate this dIxx smaller differential moment of inertia is equal to integration of y square dA. Now what happened? This integral of the differential is Ixx becomes Ixx. The is Ixx is the moment of inertia of central axis xx for this rectangle is given by integration of y square dA. Now look at here. Our elementary strip varies from 0 to d by 2 and from this 0 to minus d by 2. Because the central axis passes the centroid, so this elementary strip varies from here to here, above, and from here to bottom. So the elementary strip area is upward plus d by 2 and this minus d by 2. Here upward plus d by 2 and downward minus d by 2. So when I apply, now it is minus d by 2 plus d by 2 into y square into dA, where dA is b into dy. Okay, now which is equal to, now b is a constant, bring it outside the bracket, sorry, integration, minus plus d by 2 into y square dy. Now apply the integration b into, it is b, when you apply the integration of y square dy is y cube by 3, where integration of d by 2 and minus d by 2. Okay, and now b into, first substitute upper limit, so bring this 3 outside. Okay, it will be easier. So d by 2 means d by 2 whole cube minus of lower limit is minus d by 2 whole cube. Now which is equal to b by 3 into d cube by 2. So 2 2s are 4, 4 2s are 8, minus, now it is minus d cube, it is minus into minus plus, plus into minus, so minus into minus is this become plus, again dq by 8. Okay, now it is b by 3 into d cube by bases are same, so 2 d cube by 8. So it is 2 ones are 2 fours are, so bd cube by 12. Ixx is bd cube by 12. Similarly Iyy is given by b cube d by. Now look at here, we got moment of inertia about this Ixx as well as Iyy. If you wanted to write the moment of inertia about this base, let's say it is AB, about base. If I want to calculate moment of inertia about the central axis, the formula is known bd cube by 12. About this y by, it is b cube d by 12. But if I wanted to calculate moment of inertia about base of the rectangle, then in that case IAB is equal to, I have a formula from parallax theorem, Ixx plus AD square. Now IAB is equal to, where Ixx is BD cube by 12 plus A money area of a rectangle, that is B into D into, now this D square, in this parallel axis theorem we came to know that D square is the distance between two parallel axes. Here we have used Ixx, so from this Ixx xx about AB, the distance between these two parallel axes is this d by 2. Wherever d, just substitute d by 2 whole square. Now this become bd cube by 12 plus bd into, where d square by 4. Okay, so therefore it is bd cube by 12 plus bd cube by 4. Now we need to take the LCM, where the LCM is 12. Here it become BD cube plus, now 12 is the LCM, so 3 BD cube. So 4 BD cube by 12. So 4 is the 4 threes are. So IAB is equal to BD cube by 3. There's answer.